Hey guys, this is Mainak Choudhury. So I'm back with another video. This is the part two, an extension of the video in which I had applied seismic load and seen the analysis results of this model in the Tekla Structural Designer. So now we will apply a wind load and we'll see how the procedure for that, and also we'll see the procedure for generating the drawings. Okay, structural drawings. Okay, so let's move forward and do that. So first of all, we'll go to model and we will just apply some wind panels because I mean, for the software to understand, you need to apply some wind panels so that it can know that where to apply the wind load. So this similar procedure you have to do in ETABS also. So you might be familiar with that. In ETABS, you have to add zero weight panels. So this is similar to that. So you have this wall panel here, and this is actually rectangular in shape, and you have to add wall panels at the so-called nodes here. So you have this point. This is the first point here, second point. So you can pick the opposite column position. So this is simple. This is rectangular opposite column position. So just this one and this one. So similarly here also, you have to click this and then click this. So last one is remaining, and this one and this one. So just click on escape now, and in the visible in the this first of all, I'll just turn off the load it to avoid some confusion, and I will turn off the slab items to avoid more confusion, and wind panels I'll just turn on. So you can see the wind panels here, and you can see this is the wind panels, and you can see the various details. So it is a massless wall basically. Okay, so you can check rotate with the help of right click of your mouse, and you can rotate and see the wind panels have been applied. So when the wind panel have been applied, you can go to load. Okay, and you can validate also to see if the validation any error is there. So if there is no error, you can go to load here, and in the load we have this snow load, this seismic load which you already applied, and we'll go to the wind wizard. So we are designing this building by the Indian code. So you can see worst case data, and you can or take or untick topography. Let's untick topography for now and just go with the basic things right now. So wind level below ground level, it's 0, that is below plinth height, we'll ignore. Okay, welding from non-circular, and basic wind speed, this you need to give as per IS 875 part 3, which is the load code. So basic wind speed of this zone is 55 actually for Agartala. So 55 50 to 50, 48 to 55 the values lie. So this is 55 here, and K1 K2 factor is 1 here, and in the code you will find the various conditions where you have the K1 and K2 factors also. So here it is 1, and these are the four these provisions which is related to code. Basically these are the building where if the building is in a like on open land, then there will be more wind load. So if it's like number one, the maximum factor will be applied. So in generally this in this is buildings are open in scattered obstructions, general case, but you have to see the side to know which is there. But here it is in a populated area, so I'll select 2. And price distance, you can select 5 meter. It is basically the distance where the wind changes its composition, like speed and all. So generally it is taken as 5 meter. So and then click on finish. So once this is done, we are not actually complete with this things here. So we'll just click on wind load cases here. We can add wind load cases, and so the thing with wind load cases is you need to add the CPI value. You have this. So you have this option of auto also. Let's see, just to do auto. So you have this CPI cases of this 1, 2, 3, 4, 5, 6. Actually, this at 0 degree, at 90 degree, 180 degree, 270 degree, and all they are applying at a CPI of 0.2 minus 0.2, like this. they are applying. So you can apply this automatic also, but I'll just go forward and delete it, because the who have done in ETABS, they already know that how we apply the load. So basically we just need to understand the your coordinate system first. So this is the x, and so if a wind x, if we want to add along the positive x-axis, that is the windward phase. If the windward phase is this one, that is the positive x-axis, then it is a 0 degree angle. Okay, so let's add this here, knowing this. So we'll go to this, and we'll just click on add, and direction is 0, and wind 0, and I'll not call it 0, and I'll just call it wind x plus. Okay, so it is a windward side which is acting from the like x or y direction. So x plus, we'll call it, and in fact x plus will be that this side. So x plus we'll call it, and this CPI will be your will give it as your 0.8. Okay, and CPI 0.8 will give it, and then we'll just add another one, and it will be at deduction. If this is 0, this is 0.8, 90, and then 180. So at 180 it will be your 0.5, and we'll just add another one here. Okay, and then it will be at your this will be at negative y direction. So this is plus y, then it will be minus y, means it is at 90 degree. At 90 degree it will be 0.8, and then we'll add another one, and then it will be at the remaining factor, which is, we have already 0 and 180, so it will be 270, and it will be 0.5. So like this you can apply, or you can apply, see the code and calculate the CPI value. So I'll do a detailed video on how to calculate the CPI values exactly, and then apply. And so this is just for reference for now. And those who have done applied the Windows ETABS, they are pretty familiar with this, and we do have an accurate process of applying this as well. So we'll just click on OK here, and the basic wind loads have been applied. So once you have applied all the wind loads, you just click on the combination, and you go for the generate. Okay, and then click on next. So you can apply the wind load by both auto and this calculate the CPI values and then do it. So you can do by any of these method, and then just click on OK. So once you do that, just you need to go to analyze, and analyze all static, or you can just go to design and design all static here. So if there any error, so mostly some more members will fail due to this wind load. And now what we'll do, we'll just try to make all the members pass, and then we'll work with. And before working, just we'll go to the scene content, and then turn off the uh, layers which we don't want. Okay, so these are the results. Interesting, and you see, after applying the wind load, this we get the results here. So we are getting results here, fail in 300 into 350. So 300 to 350. Let's see. Right click, and then just let's just design member see in which it is failing. If it is failing in, let's see. Okay, spelling in stirrups. So simply they are saying that if you just increase the size, then the stirrups will be accommodated. But this is not a very serious thing here. But still, since we are generating the results, we'll try to make it pass for 1 second, and then just group it, and then we'll just change the size here. So I think 300 is enough. I'll give it 450, or let's give 450. Practically 400, more than 400 should not take. So let us give it a chance at 400, and design selection will do static. Let's see. So yeah, so it has passed, but it shows some warning also. This, I think this one was not selected, that's why, but it has passed now. So it will show warning of this thing, but that is not an issue. So we'll do that and right click and then design member static. So I think there is a warning of axial load now. All the steps is also passed, axial force loading. So we're good with that. That comes here. That's why you prefer other software, because you cannot, almost very difficult to generate a clean report if you're designing as per Indian code. But I've designed some buildings as per the foreign codes, British codes, yeah, UK, US, UK codes, but they are fine. So they are not very optimized as per the Indian codes. Still, I would give my feedback as a professional structural engineer. Give that okay. Okay, so let's look at this portion, and let's go to review, and let's look at the ratio here. So as per the ratio, everything is fine. It's all the reinforcement they are passing. So I think we don't need to meet to any changes we need to make here. Like, let's suppose this beam, it has supposed to take the maximum load. Let's see the reinforcement which it is getting here. So 2 bars of 20 and 5 bars of 16, and here 2 bars of 20 and 3 bars of 16. So I think that is pretty much okay in terms of the reinforcement and all. So we'll see and how to generate the output results here. So first of all, it's better if you open AutoCAD beforehand, because nowadays AutoCAD takes a lot of time to load. Just for the first time if you are opening it. So just go to draw, and the first thing which you want to take is the foundation drawings. And I tell you once again, as a professional structural engineer, that the drawings which you generate out of Tekla, you cannot use it directly if you are planning to do so, because you have to present it in a way. If you have seen my video on how I present my drawings, you can see that. So there has to be a lot of clarity in the drawings. You just simply cannot just give the software generated drawings, but it helps us in some way, to some degree, in presenting quick plans, quick drawings. So it can help to do that, but still I'm showing you how to generate the drawings, since this is a useful feature, I'll tell you. So basically we'll go to this levels, and first of all I want to do the first thing, which is the foundation and column layout. So foundation and column layout will take using this. So first I want the column layout. Okay, so I'll go to draw, and I'll go here to let's say a general arrangement. So this is my column layout. Okay, so not use this, I'll just use my just define a location for this, and then I'll just use this. So in desktop, I'll just create a folder so that we can view it later. I'll just name this saved TSD, short form for Tekla Structural Designer, and save TSD drawings. I'll just save this file, and I'll name this file all by all. So this is my column, name it column. This is column layout. Okay, column layout. So one by one, I'll just make sure all the drawings, and I'll compare with my drawings also. Why I say you cannot use it directly, just click on OK. So column layout automatically, since AutoCAD is open, since it opens in AutoCAD. So here you have the column layout, and you don't have any grids actually, but you have the column names. Okay, the details of this column layout I want now. Okay, so for the details, I'll go here, and I have the column schedule. So all the 3 types of columns, obviously, I want, and okay. And again, I'll not use this. I'll just use my name here. Sorry, not my name, this default name. In desktop, the folder which we had made, where is it? Save TSD drawings, yeah, forget. So it is the column schedule. So simple as that. Now in all the column schedule, you see the yeah, here you see you have this 4 bars of this A represents 16 mm, so you have 4 bars of 16 mm, and B represents the this tie for the column, and it is given the spacing of 250 mm. So the column size is 300 into 300. So like this you can find, and the levels also you can see the head, this column will go on out of the headroom, so it is a different type. So all these things you can see here, this column layout, and this we have the table here as well, and the total length of this bar is also given. So this is pretty much useful. You can total kg and mass of bars also you can find out. So this is a useful picture, and this is it. So then the call after the column view, I want the foundation layout. For the foundation layout, is simply have a separate built-in option for the foundation layout, and I'll just go around and just go to a desktop and then the folder, this one, and I'll name this foundation. Already this is there. I'll just shorten the name here, foundation layout. Okay, just click on OK to open in AutoCAD. If you have a system running on AutoCAD, memory is an issue, so I'll just delete, sorry, not delete, close all the previous files which I've opened, so that it doesn't take up that much memory, and the system doesn't lag, because TSG itself is a heavy software. Okay, so this is the these are the foundation sizes which I have this. And the beauty of this foundation layout drawing is that we have the foundation sizes, foundation layout, and along with that we have the details here as well. For the bottom bar, you can see this here, 12 bars at a spacing of 150 we have here, and we have the foundation depth and the length as well. Top 10% we hadn't ticked, therefore it is not showing. You can, if you tick, then it will also be there. Then the bar details, total bar length, and the bar masses are also present here. So that is a good thing here in the foundation layout. Let me close this foundation layout for now. Before opening other drawings, I've not got to close AutoCAD. So foundation layout, we got column layout, we got. Now for the beam. So let's take out the beam thing first, and this is the base. And so this is the base here, and this is the actually the plinth level. So the plinth beams layout, if you want. So the naming. So just click on this. You have this general arrangement. General arrangement. Just click here, and just again I'll use the, not to use the by default thing. I'll use here beam layout. Okay, and click on save, and just click on OK here, and you have the beam layout present with you. And in here, in this case of beam layout, we only have the beam, and obviously you have the scaled sizes here. Suppose you want to see this size, but this is, if this 300 or not. So this is not scaled properly, but this is 300. Okay, so the scaling of the dimension, they are not done, but it is accurate as per the, when the dimension you have to set, then you are good to use this as a layout plan. Okay, so this is the layout plan which you get. And then what about the details? So details are a bit confusing, but still I'll tell you how to just read the drawings out of it. So you have the beam schedule here. Just simply, again, I'll not use the by default name here. So we'll go to desktop, and not this desktop, this one, and THD save THD drawing. So beam schedule, shorten the name. Okay, beam schedule, this is PB, a short form for plinth beam. Okay, same thing you can do with the roof beam also. So I'll not show the roof beam, just the plinth beam will show. See, there is the same thing you can do for the go to the roof beam level and do it. So just don't get confused by all this. So see the maximum bars in the bottom. So 3 bars of 16 means 3 bars of 16 is the maximum at the bottom, and 3 bars of 16 here, 3 bars of 16 is here as is the maximum at the top. Similarly, if you are to see this, there also 3 bars of 16 is the maximum here. And then just don't just go into that much details here. So you can see that 3 bars of 16 are mostly the maximum bars here. So top and bottom, all the beams have the same size, 300 into 400, and all the beams have the same reinforcement in top and bottom. There is 3 bars of 16. So don't get confused by too much of details which is present here. And the stirrups at a spacing of 150 it is passing. So there is no problem in that, and just don't get confused by the too much details which is given here. So you will not be that much worried. So plain beam details we saw here, and similarly we can generate the roof beam details as well. So these are the main things which we need in a plan. And for the slab design, I always recommend Excel. I won't recommend this, but you have an option of slab design as well, but it will show only double reinforced bars, so it is not recommended to design slabs in it. You can use Excel sheets that are much better. I have already a video, I think, on how to use those, so you can watch that out. Okay, so this is the procedure for generating drawings in Tekla Structural Designer. And actually one viewer suggested me in the comment to make this video on how to use the drawing, so I made this. And if you comment on further on which video you want, I'll definitely make sure I make a video, and obviously like the video because it helps me to reach out, and it helps the YouTube algorithm, and also consider subscribing this channel. Keep learning, and do comment if you have any doubts or any video you want to see. Thank you. Bye bye.